All right, folks, this is just a quick video to try to help you break down the different types of problems in uniform motion questions. So I am going to start with these Caroline needs vanilla ice cream problem, and I'll try my best to work through it quickly so that you can see all three types of problems. Caroline needs vanilla ice cream. After school, she leaves on her roller skates going about 12 miles per hour. Ashton also needs vanilla ice cream, but she leaves 10 minutes later on her moped going 20 miles per hour. How long before Ashton catches up with Caroline? So this is one of those situations where you have someone leaving and someone leaving after, which means you're trying to catch up with someone, which means you want to know when someone's distance is equal to another person's distance. So once you create your equations, what you'll do is set the distances equal to each other. And again, this is a Google sheet, so if you have the Google sheet, you can do it along with me and fill it in as you go along, and hopefully it should light up for you. So I'm going to break this down using a table. So C for Caroline, I think, C for Caroline, and A for Ashton, and I'm going to go back to that old familiar rate times time equals distance. The rate that Caroline is going is 12 miles per hour. Ashton is going 20 miles per hour, speedy on her moped, and one's leaving 10 minutes later than the other. So that means somebody is on the road for 10 minutes longer. Who is it? It's Caroline. Caroline is on the road for 10 minutes before Ashton even starts. So Caroline's distance is 12 times t plus 10, and Ashton's is 20t. We just talked about the fact that this is when distance equals distance. So to set up this equation, it's going to be 12 times t plus 10 equals 20t. I'm not going to solve it for you because I feel like you can do that on your own. So I'd pause the video, solve it, and then let's get on to the next one. All right, so the next problem is, I can't erase. Well, that's the first problem. The next problem is, wow, it's weird that they won't let me erase. I gotta go again. Stop it. Oh, I guess I can do this. So weird. Okay. Anyway, Henry and Henry live 38 miles apart. One morning, they decide to meet somewhere in the middle for strawberry ice cream. Henry rides his bike at 14 miles per hour, and Henry walks at 5 miles per hour. And we're trying to figure out, if they both leave at noon, what time will they meet? So what I'm going to do is, again, create one of those rate times time equals distance problems. And so this is Henry with an I, and this is Henry with a Y, and it's rate and time and distance. Same format. So I know Henry with a Y is going 14 miles per hour. I know Henry with the I is going 5 miles per hour. I know they leave at the same exact time, so that means their time is both t. Nobody's on the road longer than the other. So my total distance here is 5t and 14t. Okay, because we just multiply, get that. Now, what we're doing is taking two people and having them walk towards each other, and we have a total distance of 38. So in order to solve this, it's going to be d, not equals d, but d plus d equals d, meaning each person's distance added together to get a larger distance. So in this problem, it's going to be 5t plus 14t, having all kinds of issues here today, equals 38. And again, I'm going to let you solve that on the own and make sure that you're solving what time will they meet. Okay, I'd pause that now, solve it, make sure you did okay with it, and then tune back in for Alana's problem. Again, it's still not erasing. All right, here we go. Alana would like a chocolate sundae. She heads to Reasons to be Cheerful at 10 a.m. She drives 18 miles per hour. On the way home, it says on the say home, but it's on the way home, her car breaks down, so she has to walk. This is 15 miles per hour slower than on the way there. This takes 30 more minutes. What time does she get home from her ice cream adventure? So same thing as we did 2 seconds ago, only this time it's a loop. She goes and she comes back. So we know it's going to be D equals D. So 2 and then home, right? Still rate times time equals distance. Her rate going as 18 miles per hour. Her rate going home is 15 miles per hour slower. So 18 minus 15 should give you 3. All right, so now we need to look at the time. she takes 30 more minutes when she's walking slowly. So that means that when she's walking slowly, she's on the road for longer. So the 2 would be t, and the t plus 1/2 would be the slower walk, and a half because 30 minutes is a half an hour. So the distance to is 18t, and the distance home would be 3 times t plus 1/2. Because it's a loop and you go and come back, we know that it's d equals d, or 18t equals 3 times t plus 1/2. And yep, there's a nice shortcut that you can do right there. Good luck.